is a short introduction to assignment 2, the A-star Pathfinder assignment. I'll just warn you, this is one of the more challenging assignments in the entire course, and unfortunately it falls right in the second unit. So I'm going to record a short video to help you out with this. So in the assignment we've made some simple changes to the A-star algorithm. Let me bring up that code. So here's the A-star file within our source code in Eclipse. So I've just opened up the A-star Java file. I'm going to scroll down, and this is our calculate shortest path method, which does most of it. We have a start goal and a node and a goal node that are set, and then we're going through this loop. We're checking out each node and building our tree. We've added some things here, so when we have nodes on our frontier list, when we explore a new node, we look at all of its neighbors and add those neighbors to the frontier list. And we've done a couple things now. We're now sorting the frontier list, so after we add elements to the frontier list, we sort them. We also calculate an estimated heuristic distance from this new node that's on the frontier list to the goal. We calculate a distance there, and then we figure out our total distance is the distance from the start to this neighbor, and then add to this the estimated distance to the goal, the heuristic distance to goal, to get our total goal. So each neighbor has the distance from the start, the heuristic distance from the goal, or to the goal, and then this total distance. And we add this neighbor to our frontier list. But this isn't going to always work. Let me show you a particular problem after I pet my cat. Just wait a second. Okay, so let's look at our map here. We're going to go from goal, start at St. Scholastica, node 1, and go to the mall, node 11 here. So let's just run our basic algorithm that way. So I'm going to go here, open up the main controller, and run this. It's going to find a path that goes from 1, 2, 3, 8, 9, 10, 11. So let's see what that does. 1, 2, 3, 8, 9, 10, 11. So it finds this path to the mall, which is a good path, but it isn't the shortest path. And the problem is that there's a shorter path that goes 1, 2, 4, 5, 10, 11. But it finds this path first, or it explores and gets to 10 first from 9. Then later on it's going 1, 2, 4, it explores 5, but it checks and 10 is already on the frontier list, so it doesn't add it to the frontier list. But we've actually found a shorter path to 10, which is on the frontier list. So we should reset our path to this. So let's look at how we might do that. Back in our code, we check when we're checking all the neighbors. In this case, let's say we've already added 10 to the frontier list after exploring 9, and now we're exploring 5, and we're checking the neighbors, and we check 10. So our current node is 5, and our neighbor node is 10 here. So the frontier list contains the neighbor. It does. 10 is already on the frontier list, so we don't do this. But we still have to check if the distance, the neighbor distance from start is less than the neighbor dot distance from start. Let's see if that makes sense. We need to check if this new distance from start that we've just calculated is shorter than the neighbor's, in this case 9, the neighbor's distance from start. So we have to calculate, see if this new distance is less than this other distance from start. So there's these two distances. One's using the actual neighbor and what's stored in the neighbor, and one is the new distance we've actually calculated with the new path. If this new distance is shorter than the others, then we have to do, like we did up here, this code, we have to do the same sort of code down here, if that case is true. Now, if this is correct, I'm going to jump to a version that is working, and I run this. my new path should be 1, 2, 4, 5, 10, 11. And that's this path, 1, 2, 4, 5, 10, 11. It should find this path. So if your code works and you're going from 1 to 11, it should find the 1, 2, 4, 5, 10, 11 path, which is the shortest path. So see if that helps you out in this code, and see if you can try it out. If not, post questions to the discussion board for Unit 1 and 2, and we'll try to answer those.